Let's move now to a problem that deals with a weak base. And what I want to do is to do a slow walkthrough on this. I want to illustrate the entire thought process. This is a little more challenging problem, and it gives a good chance to illustrate exactly what I mean when I say you need to head east, you need to extract the data, you need to analyze it, and only then do you set up and solve and test your answer at the end. So this is a very, very good problem. A lot of the problems in the notes, no doubt, I don't have time to work everything through very, very slowly. When I put a problem on the board and I show you all of the work, I'm assuming that you can go through this, and I've written enough text, provided you with enough, that you can follow that thought process. But nevertheless, I want to go back and illustrate that for this particular problem. Okay, so let's begin. Let's do our initial extract the data. Calculate the pH. What this should pop to your mind is immediately this pulls some things into play. What I know is this is where I'm trying to get. Whether it's through one of these parts or directly to pH, this is where I'm trying to reach. Okay, so let's continue on. Of a 2 molar solution of ammonia. So why do I say uh-oh? Well, we recognize ammonia as a weak base. So that means two things. One, I'm trying to report something as an acid, and I'm actually going to work with a base. That could be a little tricky, right? And that's the uh-oh. But one thing we are not afraid of with a weak base is we already know really how to get the hydroxide concentration. By the way, now I can possibly see a link already to solve my problem. Maybe I'm going to use this to get here or here, and then I'm going to go to the final answer. I don't really know where we're headed with this, but you can already see as I'm extracting the data here that already the analysis, and it's hard for me not to jump ahead and want to go ahead and solve it, but I'm going to go ahead and read through the whole problem, extract all the data, and then I'm going to go to the analysis portion. Given pKa, now there's another uh-oh. Why? Because I'm asked about a base and I'm given information about an acid. Okay, I think I see why this is a slightly harder problem. I'm going to have to connect some dots here to get this to work, but I'll worry about that in a minute. As for now, I'm just going to very calmly extract the data and write it down. So I know for ammonium ion, so maybe somehow I'm going to relate to this over here. I'm not sure what I'm going to do, but I do know this. I'm at the end of the problem, and that's all of my data. So let's now begin our analysis of this. So what do we have? Well, we've already started. We know we're trying to get here. So we're trying to use anything that will calculate any of these, either of these four. And we have some candidates that might help us get there. Now, the key thing you need to do in a chemistry class is when you're asked about a compound and it's involved in a chemical reaction, write the chemical reaction. So let's just write down the formula for ammonia. Uh-oh. Why? Because I'm trying to relate another uh-oh. I'm trying to relate ammonia to OH. But guess what? There's no OH in ammonia. This would be very easy if I had like calcium hydroxide, if that were the base. And I know that that's going to give me calcium 2 plus 2 HOs. And now I easily have a chemical equation where my hydroxide shows up. And I can just do the Rice equation on this, calculate OH at the equivalence, and now I'm done. But guess what? It's not quite that simple, is it? Okay. So, but that's okay, because I know this is a weak base. And what was one of our definitions for a base? It's something that generates a hydroxide in water. Well, guess what? If this doesn't have a hydroxide, then this is one of those longer equations that you have to put water into the mix. Bingo. And now we have a hydroxide. This is what we hope. This is what I hope will eventually link me into here. That's where I'm trying to get to. So How am I going to do it? Well, first of all, I'm only interested in equilibrium concentrations. So that automatically tells me it's rice. But I'm not going to go to the trouble to do an entire rice equation. Why not? Because we have a shortcut. We have a shortcut right there that I'm going to use. And so let's just try that. Because if I can get here, if I can substitute this and get this, I can jump all the rest of the way. So, but there's a problem. Because to get, oh, I drew this arrow in the wrong place. Hang on. This is going to get me there. So you can see, and I do this normally when I'm solving a problem. I literally try to connect the dots. And you can see me just literally draw arrows. And usually I do this on paper. I'm not smart enough to do all this at the same time or just think I'm going to throw some formula at it. It's all going to work out. So you work from the answer back to the data that's given until finally you can connect all the dots. And that's what the analysis is. You have data that's given, and then you have your final answer, and you work back from the answer to figure out what you need, and you work forward from the data, and you literally try to connect all of those things. So does anyone see the next problem that we have? I do, because to get this, so let's see, we're really good. So we're going to get here through this equation. So let's now look at this equation, okay? And we do our normal check. Do I know this? Well, of course not. That's what I'm looking for. Do I know this? Yes. Do I know KB? No. But can I calculate it? Can I look it up? No, it's not given. Can I calculate it? Actually, I can. And now the problem is going to be complete. If I can calculate that, I can... Okay. I don't know if I'm going to edit that out or not. It's 10 o'clock in the morning. Okay. Let's see. Where was I? Right. So I know if I can calculate KB, which I'm claiming I can, then I can calculate this. If I can calculate this, I can go to there. If I can go to there, I can either go take that path or that path and get to the answer. Great. All I need to do now is back into KB. And I know exactly how I'm going to do that. Let me remove that arrow, put those back. And so, see, I'm going to keep working backward. So how am I going to get that? Well, how I'm going to get that is I know pKa plus pKb is equal to 14. Yes? Okay, and so I know once I solve for, and I know this was given, and I know this, so I can now calculate this. And once I calculate this, what can I then calculate from it? That will give me, I can calculate using the minus log relationship, KB, and now I have it. Now, boom, I have it. I can use that to calculate this. I can then use this to calculate this, and I can use this to calculate this 2 different ways. And so now I'm through with the analyze, the hard part. So the next thing I'm going to do is just to set up and solve this and test my answer. And this is just the mechanical part. This is the math part. This is the part that normally when people do, they think they're grasping chemistry or physics, and they're not. They're grasping the fact that they can do algebra or calculus. So me go to the next page and show you what this looks like more cleanly written. Now I'm going to talk you through it. Now that you see the path that I'm taking, I'm going to now show you what that looks like. And this is what my test paper would look like. And then when I turn my homework in or whatever, here's how I would go about solving it. So let's go through this. We have an equation. It has a KB. We need to know this KB, and we need to know this hydroxide concentration. Why? Because if we know KB and we know the initial concentration, we can calculate this. And this is what's going to get us to POH, and POH is what's ultimately going to get us to the pH down here. I can see that. Now it's a matter of just going through that math. How did I choose to do it? Okay, so let's look at this on the side. The first one of these calculations that I chose to handle was basically starting down here at the pKa and pKb, and I'm literally going to walk myself through this. And this is how I really did the problem. I mapped it all out, and then I came back and started here, and I just walked myself through it. Right. Okay. So if I know the, so let me do this. Yes. So for this first one, I know I don't know this. That's my unknown. Yep. But I know this and I know this. It was given in the problem. Yes. That's part of that. And this right here was given. And so I calculated pKb. From pKb, I calculated Kb. Now I know Kb. Great. I can now use Kb in my shortcut in my rice formula. My shortcut, right, is the result of the rice. So if I call it the rice formula, this is it. Why? Because this results from you doing the rice thing the long way. Okay. Oh, by the way, as a quick aside, I did a quick check. I looked at my initial concentration, and now that I know Kb, is Ka larger than 100 times Kb? And the answer is, you bet it is. So my shortcut's good. Okay, on an exam, I probably would have just cut straight to this, but I just want you to see this is a really, really valid thing here. I don't need a quadratic. Okay, so I now know Kb. I now know the initial concentration. I just plug that in and get the hydroxide ion concentration, right? So if you're following along on what we did before, I'm just literally went back and did this, and then I followed up here and did this. And now I'm moving to here, and now I'm going to jump over to here. And I think the way I chose to work it is to go down here and then over here. Okay, so you can see that. Right. Okay, so what do we have? We've got pH. So I went ahead and converted that to POH, and then I've converted POH to pH. Okay, so there we go. So I have just set up and solved it, and I'm claiming my answer is the pH here I'm claiming is 11.28. So let's test my answer. Does that make sense? Yeah, it kind of does. I would expect, because this is a weak base, I would expect the pH to be above 7. And this is, so it's not much, but it's kind of at least headed in the right directions. And that quick check is for those of you who found this and you didn't do good accounting. And once you did that minus log thing, in your mind's eye, you were thinking, okay, I just did the minus log thing, so I did pH. But you didn't. And you would have caught yourself, even if you had accidentally done that, you would have caught yourself when you said, okay, I'm going to test my answer right quick. It's a weak base. Would I expect the pH of a weak base to be 2.7? No. No, you wouldn't. And that would remind you, oh yeah, because that's the POH that I calculated. Right. So all of this makes sense. I hope that helps. This video has just gone a little over 15 minutes. I'm probably not going to edit it much. But any rate, I want you to be able to take this type of analysis on both easy problems and hard problems. Walk yourself through, do your analysis, start with your answer, and then write down your data and see if you can connect wherever you're headed to wherever you're starting. That's it. Next topic we're going to move on to is going to be salt solutions. You've done strong acids, strong bases. You've done strong bases, weak bases. And the next thing is salt solutions. See you then.